So we're going to have a look at balancing a redox reaction in a basic solution. And to do that, we need to follow a few steps. First of all, we need to balance the electrons. Then we need to balance the atoms other than hydrogen and oxygen. Then we're going to balance the oxygen, the hydrogen, the hydroxide for a basic solution. And then we're going to do a check of what we've done. So we have our reaction. We have a dichromate ion reacting with a mercury atom to give us mercury 2+ and chromium 3+. So we need to write down the oxidation numbers for each of those elements in that reaction. So our oxygen will be -2, there's 7 lots of it, gives us -14, plus the -2 here gives us -12, divided by 2 ensures that the chromium is +6 oxidation state. It goes to a +3 state. Our mercury in its elemental form will have an oxidation state of 0, and it goes to a +2 state. So we can now write our two elements that are undergoing oxidation in that reaction. Chromium goes from +6 to +3, thereby gaining 3 electrons. It's being reduced. And our mercury goes from 0 to +2, so it loses 2 electrons in that oxidation process. The next thing we need to do is write the number of atoms that were present in the original reaction. So even though we only have one chromium on the right hand side, we started with 2 on the left, so we write down 2 atoms. Our mercury, we had 1 atom going to 1 atom, so we write the 1 down there. This enables us to look at the total number of electrons that are transferred in the oxidation and reduction half reactions. So we multiply through our electrons per atom by 2 atoms to give us 6 electrons, and we multiply 2 electrons lost per atom to give us 2 electrons in total for the mercury. This enables us to balance the electrons across both half reactions. We see that we've got 6 and 2. We look for our lowest common multiple, which is 6. So we multiply through by 1 to give us 6 total electrons gained by the chromium. We multiply by 3 by 2 to give us 6 lost by the mercury in the oxidation half reaction. We then use these multiples in our original reaction for our atoms other than hydrogen and oxygen. So in our reaction we've got 2 chromiums, so we only need to have 1 as the prefix here, reacting with 3 mercury from this one to give us 3 mercury 2+ and 2 lots of chromium. So we're now balanced for our electrons, we're balanced for our atoms other than hydrogen and oxygen. The next step is the balance for our oxygen. On the left hand side we have 7 oxygen and we have no oxygen on the right hand side, so we need to add 7 oxygen on the right hand side in the form of water. So we add 7 molecules of water on the right hand side. This leaves us with a deficiency on the left hand side of hydrogen ions. So we've got 7 times 2 is 14, so we need to add 14 hydrogen ions on the left hand side. But remember, this is a basic solution, so we now need to balance for the hydroxide ions. Fifth step. Now remember, with our hydroxide ions we need to add them to both sides. To balance the 14 hydrogen ions we need to add 14 hydroxide ions, which will give us 14 water molecules, but we also need to add 14 hydroxide ions on the right hand side. So if we now move down we can get our final reaction. We've balanced for electrons, atoms, oxygen, hydrogen, hydroxide ions. So we end up with, we've got 14 water there, 7 water on this side, which leaves us with a net of 7 water on the left hand side, plus 1 dichromate ion, plus 3 mercury atoms, gives us 3 mercury 2+ atoms, plus 2 lots of chromium 3+ atoms, plus 14 lots of hydroxide ions. Let's check how we went. Our chromium on the left hand side we have 2, and on the right hand side we have 2. Our mercury on the left hand side we have 3, and we have 3 on the right hand side. Our oxygen atoms on the left hand side we have 7, and we have 7 on the right hand side. Our hydrogen atoms on the left hand side we have 14, and on the right hand side we have 14 as well. And the last thing we need to do is balance for our charge. On the left hand side we have 2 minus in total. On the right hand side we have 3 times 2 plus, which is 6, plus 2 times 3 plus, which is another 6, gives us 12, minus 14 lots of minus 1, gives us minus 2 on the right hand side, which goes with our minus 2 on the left hand side. So that's our balanced redox reaction in a basic solution.